supposed to.
Recording in progress.
Okay, there we go.
It's today, the 22nd. Yeah, Beaufort.
Okay, anyway. Okay, so this is gonna be the last little section of chapter 19. And it's gonna be synthesis of aldehyde state ketone. So we talked about reducing. Aldehydes and ketones to alcohols with like sodium borohydride and stuff like that. We can also go the opposite direction. So we can oxidize alcohols into carbonyl groups. So we have an alcohol like this. There's a couple options of different reagents we can use. And those will all get us to a carbonyl. So the ones we'll talk about are these, PCC, DMP, or the Swern oxidation. You can also do this for primary alcohol. And in the same way that if you take a secondary alcohol, oxidize it to a carbonyl, that ends up being a ketone. Take primary alcohol and oxidize it to get an aldehyde. You also might ask, okay, what happens when we try and oxidize a tertiary alcohol? And the problem with that is, well, you can't make a double bond because we've already got 4 sigma bonds to carbon. And so the tertiary alcohol is not going to undergo oxidation like this. Okay, so what are these reagents? The first one, PCC. It's pyridinium chlorochromate. So that's the pyridinium ion. And then the chlorochromate looks like that. Okay, the next one, DMP, is Desmartin periodinane. I spell that right? Periodinane, yes. And so it's got the iodo bit in it, so it does contain iodine. But in a fairly strange way. The iodine in a ring. That's bizarre enough. And then it's got 3 acetyl groups attached to it. Acetate. And then the final option is scoring oxidation. And that requires a combination of reagents. So we need dimethyl sulfoxide, DMSO. Plus oxalyl chloride, which is like an acid chloride, but on both ends. And we need some sort of base. So these are sort of the 3 standard ways to oxidize an alcohol to a carbonyl compound. They all have significant drawbacks to them. And so you kind of have to pick your poison. In some cases, literally. Pyridinium chlorochromate has chromium 6. Which is carcinogenic. DMP is really expensive and potentially explosive. So you kind of have to be careful with that. And then the scoring oxidation is extremely stinky because you end up using this oxygen atom to help do the oxidation. That goes away and you're left with dimethyl sulfide, which, as you might imagine, smells really, really bad because sulfur. So you sort of have to pick which one you're okay with. I would go with PCC because chromium 6 is pretty, it's a really bright orange. But those are your sort of 3 options for oxidizing alcohols. Okay, the second method. Now, this oxidation of alcohols is pretty standard. It is easy to spot if you're doing a synthesis or a reaction because you just see an alcohol like that and you're like, ooh, okay, I've got this carbon-oxygen bond. I want that carbon-oxygen bond, but I just want it to be a double bond. Well, you have sort of a selection of different ways you can do that. But you may not have an alcohol just sitting there to be oxidized. So another option we've already talked about is the Friedel-Crafts acylation. Friedel-Crafts alkylation is not, I mean, that doesn't give you ketone of any kind. So just as a reminder of what Friedel-Crafts is, we take our benzene ring, treat it with an acyl chloride or an acid chloride, whatever you want to call it, with aluminum chloride as a catalyst. And that's just going to form a carbon-carbon bond between the carbonyl and benzene. Primary drawback here is that only make aryl ketones. And when I say aryl ketones, I'm talking about this, the fact that you've got to have the carbonyl directly next to an aromatic ring or a benzene ring or something like that. But if that's what you're trying to make, this is like the classic reaction to do that in chemistry. Yep.
All right, can you say that again? You said, what is arrow?
Aryl ketone is, well, this is really the definition of an aryl ketone. When you've got a carbonyl, or it has to be a ketone, we call it aryl ketone, but a carbonyl right next to benzene. So third method is actually to do a Grignard reaction. Okay, that sounds odd because we know that the Grignard reaction takes a ketone or an aldehyde and makes an alcohol. And that's true, but in this case, we're going to do a Grignard reaction with a nitrile as the electrophile. The way that's going to work is there's our nitrile, and a nitrile is not the same thing as the normal sort of aldehyde and ketone that we use in the Grignard reaction, but it's essentially going to work the same way, where we've got an electrophilic carbon and some pi electrons. Anyway, we're not going to talk about the mechanism of that or anything, but if we treat it with kind of the standard Grignard reagent type thing, so in this case, phenyl magnesium bromide, which is that. The product of that reaction is going to be a ketone. And it's going to have the R group from the original nitrile and phenyl group from our Grignard reagent. And as a reminder, that carbon atom is the central carbon atom that gets Grignarded, the verb, Just made that up. Okay. Yes. Yeah. Too expensive in reports.
I know, I had hopes.
Also, I don't want to get sued, but yes.
You drew out the MGBR as attached to a benzene.
Yes.
Like, so can we just assume when we see MGBR that it's attached to a benzene or?
No, because that is phenol.
Oh, okay, I see.
Yeah. Okay, the fourth and final, well, it's not good. There's plenty of other ways, but the one we're going to talk about, the last one here is alkene ozonolysis. Did y'all talk about ozonolysis? No. Yes, I got a thumbs up and a thumbs down, so, all right. That's okay. Okay, so if we take an alkene, and let's say it's got R1, R2, R3, R4, just to keep track of the different groups. If we treat this with ozone, O3, and then dimethyl sulfide, again, stinky, but sometimes necessary. This does something cool and unusual, and it basically cuts the alkene in half like that, and replaces sort of this area with an oxygen atom on both halves of the molecule. So R1, R2, oxygen, R3, R4, oxygen. So if you want to flip those around, those are the two ketones that you get from an ozonolysis. It's also okay if R1, 2, 3, 4 are hydrogens. So alkene like that. Under ozonolysis conditions, you should probably again do this thing and say, all right, we're just going to split that in half. And you don't even have to do any of this rotating things around to make it look nice. Say, all right, there's the first half, that's an oxygen, and the second half, like that, and there's an oxygen. So in this case, we've made two aldehydes, and you can make that more explicit if you want by putting in those hydrogens, but not required. So that's ozonolysis.
Said it's not required to put in the
The hydrogens,
just for that one, or?
Nope, for any aldehyde, you don't have to draw the hydrogen. It's kind of just customary. So. Either of those two are the same thing. I don't know, this just looks, this is what I look for when I look for an aldehyde. But it's just a carbon hydrogen bond that you don't have to draw, just like in any other one. Yeah. Okay. All right, give this a shot. This one. Severe weather.
I saw you do enough that it's good.
Relative humidity values of 25% or less can be expected. That's a good thing.
Yeah.
Okay.
Oh, what? Oh. You just need a block. I know. You should. Didn't ask me. It didn't say anything. Yes.
So it's only gonna break the double bond. So that single bond on the other side is gonna stay intact, and that means that you're not gonna have two separate molecules as a product, you're just gonna have one molecule. With two carbonyls on it. Yeah.
Yes. Pretty scary.
Well.
Yeah. Yeah, I got it. But it's not got one.
Yes, so this is a.
Yes.
Six, so this will be into.
But it's not.
I'm fine, the only one I can figure out.
Wait, me.
They wanted the double line. Yeah, it's just one that's two.
I would think this.
Like that. Okay, so you, I didn't have to go out with that.
So, why did sort of academic?
Okay, I guess just start over here, so.
The trouble box too, actually.
Okay, so this one here is, we'll have a Grignard reagent, the tert-butyl magnesium bromide. And we have a nitrile. Okay, so we know that that carbon on the nitrile is going to become a ketone. And what is the other part of the ketone going to be on this side? Well, it's going to be that carbon fragment that was attached to the magnesium bromide. So that's one carbon there with three methyl groups attached to it. Okay, this one we have a secondary alcohol, and we're reacting that with DMP. And so that's just going to oxidize the alcohol to a carbonyl, whether it be a aldehyde or a ketone. In this case, it's secondary. So it's going to be a ketone. So ozonolysis reaction, that means we're going to slice the double bond in half. In this case, the double bond is going to get sort of cut, so to speak. But the single bond on this side, it's not a double bond. So that's not going to get broken. Okay, that means, well, if we split this apart, it's still going to be one molecule. It's attached around this side. So I'm going to draw it kind of like that. And then carbonyl there, carbonyl there. And if you like, you can put the hydrogen. Those hydrogens were originally right there. stretch it out, it should look like that. Okay, this one is pretty clearly LCl3 free to press acylation. So what happens here? Well, we make a bond between the benzene ring. Now, if there was a substituent on here, a directing group, then you have to take into account correcting effects and all that stuff, but not in this case. So we're going to make a bond between carbon on the benzene ring and the carbonyl carbon. Chlorine's going to be gone. So here's our original benzene ring. Carbonyl, and then whatever was attached to the carbonyl, in this case, it's another benzene ring. So if this is ring A, this is ring A, and if this is ring B, this is ring B. Of course, it's symmetrical here, so it doesn't matter. And then finally for this one, well, we've got a diene here, but we're not doing diene chemistry. We're doing carbonyl chemistry. So what we need to look for here is the alcohol. And we've also got DMSO, oxalyl chloride, and triethylamine, which is a type of base. So this is Swern oxidation conditions. And that's the same as DMP, basically, it does the same thing as DMP. And we're just going to oxidize that alcohol to carbonyl. So like that. And well, we can draw our aldehyde. Email from Dr. B. It's good news, not bad news. I just received word that there was an armed robbery across the street from the Bluffton campus at a bank, and the person fled on foot. The sheriff asked USCB's public safety to send out the lockdown alert in case the person fled onto the Bluffton campus. Please take this seriously until you receive all clear from public safety. Okay. It was not a shooter or anything, it was an armed robbery across the street.
What do they mean?
It's what?
The one right at the light, like, it's like on campus, basically, it's like right next to it.
Someone next to the target.
It's like
yeah,
TV, it's like
yeah.
TV or
Someone
something.
robbed that
Yeah,
thing.
they
Yeah,
was
yeah,
just
yeah.
robbed at gunpoint.
You know what?
Like, how much money do you think is even in that?
It's not robbing a bank, it's just a robbing a bank,
Okay.
especially that one.
What were we doing? We're basically.
Fled
done.
on.
Right, at that point, just like steal the car, like run
Yeah.
out of
Yeah.
You're gonna get more money from those cars.
Okay, questions on those four synthesis? Method. Okay, these are not on the homework. Just review them a little bit. I'll put some practice problems on them as well, but they're not gonna be required. Okay, we technically have one more day left of this chapter. No official lecture, just come for office hours and maybe some practice. If you like, but we're done with chapter 19. All right, so see you on Friday if you like, or on Monday. Or last day, couple labs.
Forget it.